Okay, so what do you guys think this looks like as a graph? What do you think the equation y equals 1 over x looks like? Does it look like a parabola? Does it look like a line? Does it look like, I don't know, what do you guys think? Anybody? Any idea?
It's not a line.
It's not a line? Okay. Well, how do we graph any function? Can make an xy table, right? So let me do that. A really long xy table. And let's plug in some numbers. Give me a number to plug in. How about we start with a negative number? -4. If I were to plug in -4, what do I get as an output? If I were to plug in -4 right here, what do I get as an output? Anybody? -1/4. You agree with that? Which is really about -0.25. Exactly -0.25. What if I plugged in a -2? What would I get out? -0.5. What if I plugged in a -1? What would I get out? -1. What if I plugged in a 0? What would I get out? Undefined. So I cannot plug in 0. Okay? So let's actually graph these coordinates so far. So let's go to the coordinates 4, -4th. Okay, so 4, 1, actually -4, 1, 2, 3, 4, and -1/4. -1/4 is right here. It's super close to the x-axis, right? So let me put a dot right there. And then let's go to the coordinate -2 and -1/2. So from the origin, -2 and -1/2, that's a little bit right there in the middle. And then let's do -1, -1. Well, -1 from the origin on the x and -1 is right here. So that looks really strange because I end up with this weird looking curve. Okay? And what I would like to know is what happens from here and here, because at 0 it's undefined. So you can't even plug in 0. So what happens right here halfway towards a negative? Well, let's figure that out. Let's plug in a -1/2. Now let's think about what happens when you plug in a -1/2 into the original function. So when you plug in -1/2, you're going to have 1 over -1/2, which really becomes 1 times negative, but the reciprocal of 1/2, which is 2 over 1. So that's really 1 times -2. And what do you get? -2. So you get -2 as an output. Let's see how that looks like. The coordinate -1/2 and -2. So on the origin, -1/2 is halfway, and -1, 2 is right there. Okay, so to make a long story short, it's going to infinitely approach the y-axis, and over here it's also going to infinitely approach the x-axis. So it never actually touches the, It never touches the x-axis, so your x-axis is an asymptote, and it never touches your y-axis, so your y-axis is an asymptote. Now, what if I were to plug in a +1? What would I get? Well, 1 over 1 is 1. What if I plugged in a +2? What do I get? 1 over 2 is 1/2. What if I plugged in a +4? It would be 1/4. So we could clearly see what's happening in the other direction as well. So let me graph 1, 1. So 1, 1 is right here. We said when we plug in 4, we get 1/4, which is super close, right? And if we plugged in a 2, we got out 1/2, which is right there. So it's also giving us this weird looking curve that infinitely approaches the x-axis but never touches. And in the other direction, if you were to plug in half, all right, if you were to plug in 1/2, then it would give you the output 2. So for the input 1/2, you get the output 2. And we see also that it's continuing to grow infinitely closer to the y-axis but never actually touches. So once again, your x-axis itself is an asymptote and your y-axis itself is an asymptote. Okay, so technically the vertical asymptote would be the equation x equals 0, and the horizontal asymptote would be your equation y equals 0. And finding these asymptotes makes it really easy to graph. Okay, so I hope that kind of makes sense. Now let's move on to our worksheet.